So, good to see you again. I guess we're entering to the final phase of our class. We will have five class left, and the last class will be the exam. So the very last Thursday we'll have no class because instead we have the exams. So very quickly, let's think about how to deal with the last few topics. So we have two topics, hypotesting and regression. So I guess for ANOVA, we have two parts, one-way ANOVA, two-way ANOVA. For the interest of time, maybe I would just cover one-way ANOVA. So the two-way ANOVA, if I have time, I can come back to talk about that because I want to make sure that everything is on time and I'm not rushing. That's time left over, I will talk about the two-way ANOVA. So that would be the thing. So probably, hopefully, we can speed up a little bit, but because I don't want to rush. So the goal today, of course, is talk about ANOVA, okay, and what is called the analysis of variance. So before we do that, let's quickly review what we have done in the hypothesis testing and talk about some Excel function as well, but very quickly because there's not too much Excel to work on at this one. But the main idea would be the following. Maybe I just do a right. So it will be what we learn is there's a one sample. Okay. We have the following: the Z test, right, and the T test. Okay. And then therefore mean. Right? And then we have Z test for proportion. So that is we have done, and then after that, we have do the two sample case, right? Two sample case. We have two things, t-test, okay? We have two cases. We have equal variance and unequal variance. And they are independent t-tests, okay? And also t-test for paired population, right? Which means we observe the same individual before and after, right? And the difference between the same individual we call what we call treatment effect or the difference. And the difference follow a standard normal distribution. And then everything can be done the same way. And also the C test for proportion, right? And then we have the F test for variance. Okay. So that would be the idea. So the question would probably, what we do today for ANOVA, okay, will be looking at this particular case. Okay. And in this case, we only have two samples we have done. So what happens if many samples? Okay. What happens if you're not considering just two populations, right? You consider, for example, you are an owner of many stores, right? Maybe store in Hong Kong, store in Kowloon, and store in New Territories. You want to see, say, these three areas are the same or different, right? Mean of the three areas same or different, right? Before we may be comparing Hong Kong and Shenzhen, right? or more, or maybe you can compare Hong Kong, Shenzhen, Shanghai, Beijing, many. Are they the same or different? Okay, so that is the goal of ANOVA. And turn out that when we do ANOVA, very interestingly, we will use F-test. Very interesting. Later you will see. When F-test is compare variance, and turn out that when you compare mean for different groups, more than 2 groups, turn out that you use the F-test. Very surprising, which is out of nowhere. Right? It's not even about F-test. And the F-test we do is a one-sided F-test, not two-sided, it's one-sided. Okay? We will clear later, you will see. Okay? But let me review what we've done in Excel. So that's now you know what we are doing. And then so to make sure that everyone have the same starting point, and then we go to ANOVA. Okay. So let me I think we cover all this F test, right? So let me quickly talk about the Excel. Okay. This Excel Z test, as you would imagine, is doing a right tail test. Okay. It's not a two tail, it's a right tail. Okay. That means that if you want to do a two tail test, okay, you have to say in this case you have to subtract from 1 and multiply by 2, right? If it's less than 0.5, you just multiply by 2, right? So have to be a little bit more careful about this one. Okay, you just enter the data and the mean and the variance, then you're done. Okay, so that would be the Z test. Okay, so basic data. You give data, give you the mean, and gives you this variance. Okay, so that is example that how you can do the Z test. Okay, you will do the left tail and right tail is already given from here. I'm not going to work it out, but this is the Z test, left tail, and the 1 minus the left tail. And the two tail will be 2 times minimum of the 2, right? Because at the minimum, because if this is more than 0.5, then multiply by 2 will be more than 1, right? So we minimum of the 2 number and multiply by 2. Okay. And here the blue part is we calculate from scratch, right? So telling you that actually the green thing is actually doing the what blue behind. And you're able to see how the green thing is done, right? The first line, row number 8 is calculate how many data, and you calculate sample mean on the row number 9. Row number 10 is standard error, right? Which is standard deviation divided by the square SQ, right? Because you're given the standard error, standard deviation is 2 and square root, and then you calculate standard z test, and then that is how you do the calculation. Okay, so the standardized is actually means you just calculate the mean and subtract from the mean and divided by the SD. So basically, that's how you get the standardized. Okay, standardized, just subtract the mean over the SD. Okay? So that means that you take the C9, which is number, okay, and minus C1 and divided by the SD. Okay, that is how we get this number. Okay, and you can do the t-test, but unfortunately the Excel has no t-test here. Okay, so you have to just do it by scratch. And one interesting thing probably I didn't mention a lot because I worry about it confusing. Here you can see the t distributed dot RT. Okay, it's the right tail. Okay, what is 1 minus the left tail. Okay, so you can do the what I said, right? Calculate the 1 minus the area, right? And times that, or you can do the right tail. So it's the same thing. Okay, because this is calculate the thing on all the thing on the left hand side, the area, right? The right tail calculate the area on the right hand side. So you can use dot RT to do it, but I don't do this in the class because I worry about you confused. I keep only on the one Excel function. So that's why, but I put it here. If you want to do that as well, that's also fine. And this is the two sample test. Okay, it will be the depend on right tail or two tail. It depends on this one or two. One is one tail. Okay, two is two tail. Okay, one tail and two tail. Okay, right tail. And why I have two at the end? Okay, two is what we call equivariance. Okay, equivariance. So that's exactly give you the result directly, right? So if I give a data x1 and x2, I want to calculate the t-test, right tail or the two tail, right? If you go to left tail, just one minus the first one item to the left tail. And this already gives you the answer already, right? Give two data set. I want to test whether they're same or not, right? This Excel formula. And one or two determine you are doing the right tail or two tail. And two is the equivariance, okay? So you don't need to calculate the pooled sample, right? That is we do in our class, right? So of course, here is the slide that tell you actually you can do the calculation, calculate the variance and all this calculation and give the same result, right? So you can see the green, we're saying the blue one, right? So the blue one would be you calculate N1 and N2, right? Count how many number of data, right? And calculate this degree of freedom, N1 plus N2 minus 2, calculate the mean difference, calculate the pool variance, right? And you calculate T-stat, it will be the pool variance over times 1 over N1 plus 1 over N2. So this is the formula we have seen. Okay. So this tells you the green one the same as the blue one. The green one is a formula. So just that's why once you Excel, then you don't have to worry about the calculation. Okay. Just to give you, okay, this is the p-value, you can judge where the p-value is more than 5%, less than 5%, right? So that's why that's different. Okay. You can see this slightly different from the assignment question or the slides is I give the data directly. But in the assignment, I actually give the sample mean, but usually you have only the column yellow, right? Then you calculate that. But Excel actually skip all the steps, give you the answer immediately. Okay. Hope that is clear. Okay. Same if you use unequal variance, that will be use what we call the number 3. Okay. Number 3 means the unequal variance. Okay. So the same method, right? X data set 1, data set 2. 1 is the type that is called right tail, and 2 is the two tail. So that is how you get the formula there. And this is a proof how you can do that, right? And the most difficult part is this crazy formula here. Okay. This degree of freedom calculation based on this rather complicated formula. Okay, but if you simplify, it will be not so ugly, but you can see you all do this crazy step, but the t-test already give you the direct answer. Okay, as long as you know whether you can assume equivariance or not equivariance, right? If you can't equivariance, this is how you do it. Okay, use number 3. And again, you may imagine that's number 2 there, right? Number 1 there is a two-tailed pair test, right? You give two data set, right? And I look at the difference between each element there. It's a paired observation. To note the pair observation means that the first element in 3 and second element in 3 are the same guy. Okay? And you care about the difference between the two, so it's first observation actually is 0. Okay. So you do a t-test on that. And that's how I show you the calculation in the Excel. Okay. So there's nothing there. I think there's a missing formula here. This should be the average of C2 to C7. This is average. There's a missing over here. So this is just the average of C2 to C7 is this mean. Okay. Sorry for, I don't know why I missed that, but you know that is here. Okay. And lastly, the F test, I give you two data sets. I want to show whether the same variance or not. And do note that this is a two-tail, as you expect, the two-tail test. Is that okay? So I hope that is more or less clear what we are doing. I mean, this is how we calculate the this two-tail test. Okay. But F test is so simple, it's just a ratio, right? And the only thing if you have to say is what is the number of degree of freedom of the numerator and denominator, n1 minus 1 and n2 minus 1. So that would be the thing. Okay. So I hope it's okay. And then what I want to say more is this is something we call the add-in. So we haven't seen add-in for a long time. So here is basically you can do the add-in, the t-test directly. Okay. Also, you can just get the formula and just bump up stuff. Okay. And this is the you can go to the analysis 2 and do the t-test, right? And you can just put in the same as we have expect, put in what's x1, put x2, then click OK, then the same. In this case, right? You have a bunch of x and bunch of y, tell them column A is x and column 2 is y, and you have label there, use 5%, you output in the C1. And that gives you this guy, right? And clearly this guy already gives you what is the mean and the DF, the t-stat, and the p-value. Okay. So this is something, although I put Excel, if you do in the Python or R, you will see something similar. Okay. So that's why we do this because usually this is what you get from Python. Okay. Very similar, not exactly the same, but very similar to this one. Okay. And you can do the same for unequal variance. So I would say add-in is most similar to the Python. Okay? So once you know Python, you will actually easily see how this is being done. Okay. And I'm quick on the add-in because I'm not interested in asking you how to operate it in your exam. But just let you know, okay, there's a to understand why we cover all this material in our class is after you're done with this class, you can basically know 80%, 90% Excel, that package, the add-in, everything there. You should know 80%, 90% of that because this class covers everything there. Okay, almost everything there. Not everyone, but everything that's useful for our purpose. Okay, so this is an unequal variance. You can just given data, right? Tell them and just run, already give you the answer, right? Whether you want a two-tail or one-tail, look at the p-value, right? This number, then you're done. So this rather convenient, right? Once give you the p-value. Right? So you don't need to worry about what's critical value, right? As some of you ask, okay, the critical value, it's very complicated, right? In the table I give you doesn't cover every single table, right? What happened? Because you really don't check the T critical value, right? Because the Excel or the Python give you the software, give the P value directly. So I do in the class because I want you to know what's the procedure. And same for the pair. Just tell them where you are, right? It's listed out nicely. Then the answer comes out, right? You only check the p-value, right? And this p-value are not less than 5%, so you just reject. No, sorry, you can't reject it now. Right? So the same thing. Basically, you care about the p-value. But from here, you can pick up the t-stat and the df, right? The same thing. Okay. So same for the F test, right? The F test also, I'll give you the F test based on the number there, right? And then you will be also be doing this F test, right? You can do have one tail. What's the critical value there? Right. So that would be the idea behind what we have done. Okay. So at least at this moment, I'm not interested in asking get in, so that's a little bit faster. But you will know the main goal is, of course, look at the p-value, right, and see if you want to reject or not. Okay. So if no further question, then we get into ANOVA because I want to get in more exciting business, right? Because I guess you hate too much review. Right? Something new is to be learned and it's more fun. Okay. But I think you once you do assignment, you know what you don't know. Okay. That's very important. You do assignment on your own. Okay. Of course, you can discuss with a friend, but try not to rely on some too much help from the AI or your otherwise doesn't do you good in the exam. So analyze variance. As I said, basically this is a generalized t-test. Compare more than one group, okay? And assuming variance across different groups the same. So this is very special cases, okay? So it's still very useful in many situations, so that's why I keep them. Okay, it's not something. But in general, you don't see that very often. Okay? You will be using regression a lot of time rather than ANOVA. Okay? And ANOVA can be considered a special case of regression. So you don't have to. That's why I don't want to cover a lot on that. So that's why probably I'll skip the two sample or two-way ANOVA. Just keep it one way. Okay, because if you do two-way, you can as well do regression. Okay, and then you do learn regression in the general regression in the next semester. If you ever take 2121, 2021, then ANOVA is included there. Okay, regression. So that's why I just for the very basic cases, we'll call one-way ANOVA. Two-way, probably if I have time, we come back at the end of semester. After I run regression, if there's time, we'll cover two-way ANOVA, but just for one-way. One-way ANOVA means that we talk about our data is grouped by some category, okay? Like gender, age, countries, groups, or houses, right? I think in everyone has a college, right? And they are all categorical data, right? So you can't say one group better than other, right? You can't really say you can order according to age, but otherwise you can't say by age you can say child is less than youth, less than adults and elderly, but that is only age, right? But if you talk about say where to spend on your product, you can't really say, right, in advance what is more than the other, right? Or gender, right, male and female, right? Before you do the study, you actually don't know whether man is going to pay more than woman or woman pay more than man, so and so forth. So, or country same. So that means that here we will have the data for each observation. We have the observation. It's called the variable interest X, and about is grouping. Okay? Each observation not just his number, but also we know his grouping. Okay? For example, each data I know individual one want to spend $10, and he is a children. Individual two, he spend $20, he is an adult. Individual three, he want to spend $100, he is an youth, so and so forth, right? It's number and group. Okay. So as I said, right, the data is a pair, X and G, okay? And G, you know, at the beginning, you know that at most C different types. So in male and female, C is 2, right? If age group, you have 4 types. Right? So that is the idea behind, okay? And this is the data that usually you see, but this is often the data that you collect in the database. Okay, is you collect is a we call the long format. You will see this each row is an observation, so you have the number, grouping, number, grouping, number, grouping. Okay, so this is the data you collect, and data from database is often in this way. Okay, but this is not usually most convenient when you write formulas. Okay, so the formula you write is usually write in this form. Okay, a little bit more tricky. Okay, you write in the following way: x11, the first element, is look at group number 1, first observation. x12 will be group number 1, second observation. Okay, and x1n1 is the first group, last observation. Okay, and then after next will be x21, right? The first group, sorry, the second group, first observation. So that will be, we'll put them in a list. Is that okay? What does that mean? Okay, the last one will be xc and c is the last group, last observation, because only total in C group. So we do this double subscript, okay, to make our life easy. Okay, this is the standard notation. I'm not inventing my own. You look at all the textbook, this is what they follow. So this is xij is a standard notation. So how do we see this in Excel? You see this in this way. Okay, you group them together. Each column represents a group. Okay, G1 is the group number 1, and GC is the group number C. That's a C number group. And you group them in the column form. X11 is group number 1, first observation. X12 is the group 1, second observation, up to group with the N1 observation. So we just have different columns that collect different data. Okay? And you will see I deliberately make each row, each column have different rows because it need not have the balanced observations. Okay? Now, once we have seen that, we will do what we have done so far. Assume normal, right? That we have done, right? You have 2 groups, everything is normal. We have 3 or more, 4 mine, still normal. So everything is bad. Okay, so you can imagine the idea is the following. Right, just to make sure that I just draw a table and explain it a bit better. So this is the data number line, right? From negative infinity to positive infinity, you can keep going, right? And what we learn maybe, this is the female bell curve, maybe, right? This female want to spend on your product, okay? And this group number 1, right? Girls, right? Maybe X1. And then it can be boys, right? Boys may be here. Not boys. X2, right? So this is the case where you have in the previous chapter, you want to compare the mean of the boys and girls born at the same location, or look at the variance are same or not, right? If you look at the variance, look at the F test, look at the mean, use the T test, okay? And the T test can be 2 ways. Either you assume the same variance or not the same variance, right? So this is the then now, but suppose you have another group, right? I don't know. Beside boys and girls, you maybe have I don't know. This day we have a movie, alien movie, right? What's the name? It's I forgot. Alien Predator, right? Alien versus Predator. Anyway, Alien X3. The ET, right? Some ET, right? Or some animal, whatever, right? You can see this. Then you want to see whether these 3 groups are the same or not, right? Alien visit our country, visit the world, and then see they willing to spend the product, right? So that's a 3 group. Okay. And then can be more, right? More group can be I don't know, maybe some dinosaur anyway, right? So this is many group. We're going to see that the same or not. Okay, so that is the idea. It's more than one group. Okay, and they're all bell curve. Okay, we have many bell curve. Okay. Oh, sorry, take pictures. Is that okay? But now we assume they have the same variance. Okay. So the graph I written is not entirely correct because I need to have the same variance. So basically what I need instead would be something like this, right? Same variance imply the following. We should have, this is group number one, the girls, the boys, the aliens, the dinosaur. Okay. And we want actually see this bell, assuming they're the same spread, same as whether the mean are the same or not. So that's a question. Okay. Of course, our idea is actually they're all the same, and we look at data whether they're same or not. So that's the idea. Okay. So they're underlying this guy. Okay. Can we do that? Probably yes, but we'll just focus on the simple one. If you do regression, actually you will see it's very easy to do this guy. But we're in the ANOVA thing is like 8 years ago, so that's why we're using we're old technology. Okay. But anyway, let's continue. We have each observation come from the own mean. Okay, each of them, but the value is the same. Okay, same value. Now next is sometimes you write if you say normal, which means that the observation come from the constant mu plus a bell that is center at 0 and the standardized. Okay, it means 0 normal. Okay? Not standardized, but means 0. This is usually you would write in this way, and this is usually the way you see in many kind of modeling. Is a variable will be equal to a constant term plus a variable. You say deterministic and stochastic. Some is fixed, some is variable. Okay? So let me repeat. What we're doing is x something vary, okay, about. So let me draw that. Okay. Let me draw it down. So this is very standard in many kind of model. So usually is if you have a mu I, okay, the bell curve like this, right? So we have a xi follow normal mu I sigma square. Okay. Usually you can write it as the 0 is here. Okay. This is epsilon I error term, normal 0 sigma square. Okay. And you can see xi is equal to mu I plus epsilon I. You just move it back. So usually this is a constant. So this number that doesn't change, not random variable, but this is a random variable. Okay. So this is usually when you see a lot of modeling with not 0, then you say a constant part plus a mean 0 random variable. And we often look at the regression later, next class, or look at most of many cases. This is the way we write. Okay, and it's very convenient. Okay. Basically, this is a 0 mean random variable. Okay, this is non-zero mean random. Okay. So there's always you can write a non-zero mean node is a constant plus a zero mean random variable. Okay. So you can always do this when it's normal, right? Normal can move around. Okay. But remember, this is not always doable, but because normal, you can always write this. Okay. Because this is the bell, you can separate them. Okay. And since we always assume, most of the time we assume normal when we do modeling, so there's always no problem at all. Okay. It's only good because you can do normal, right? You cannot say it's binomial on the left-hand side, you cannot do this because they're related. Okay. But in the normal, you can always do this funny property. Okay. So now we have to bear with me, we have to some definition. Okay. First is the grand mean is mu1 plus mu c over c. What does that mean? Remember, what is the meaning of mean? Mean is you go to the left, go to the right, this turn the same. Okay. So what is the grand mean over there? The grand mean will be somewhere here. Why? You go to the left-hand side, this is 2 number. Add up should be same as you go to the right-hand side. Okay? So that is, you add this mu1, mu2, mu3, mu4, divided by 4 is the mu, right? Mu is in the middle. So the mu is the grand mean. Okay? It's mean of the mean. Right? But mean of the mean is simply in the middle of all the means, right? Is that okay? And here we define alpha I as the treatment effect. It's mu I minus mu, right? Oh, I have a table here already, right? So actually, I don't need to draw it, but let me do this diagram as well, right? So this is alpha, right? The alphas. Okay. Of course, this will be negative because this minus this. The distance. Okay. So that means the treatment effect. Okay. And of course, we want to say the treatment effect or zero or not. We're going to see. Later we'll see why we care about that, right? Because original problem of ANOVA is an agricultural problem or production problem. Actually, it's the guy who want to grow the best way to cultivate a plant, right, for farming purpose. Right? And you want to see different combination of the sunlight, water, nutrition, right? And all this kind of combination, right? Fertilizers and all the thing, which would make the plant grow the best. Okay. And of course, you want to see if this all treatment effect or zero, right? If there's no difference, then it don't really matter, right? If it doesn't really matter how you cultivate the thing or so on and so forth, right? Then you can forget about what you're doing, right? If you figure out that this is not zero, then you figure out, do the t-test and see which one is better, right? Of course, you can do t-test one by one, but ANOVA is the way to do once and for all, right? So because I want to see if all of them are as anything different. Okay, later we'll see. Okay. So that is the what we call treatment effect. Right. So that's what I said, right? Look at the overall mean, look at the left-hand side and right-hand side of alphas. Okay. Our ANOVA, okay, we'll be asking at the end, is looking at all the mu the same or treatment effect of zero. Okay, so that is the main goal of what we're going to do today. Okay, before we do that, I want to introduce 2 numbers. Okay, because at the beginning we want to see what is the mu and mu I, right? And they all number we don't know. We want to estimate them, and to estimate them, we can just use the sample version, right? grand sample mean is just adding all the data divided by n. Right? So what it is, you add up each group from group number 1 to group number C, all the groups, and that's all the I. And for each group, you from the first observation to the last observation. So it's just basically just simply adding everything divided by n. Okay, just add n. You forget about the grouping. Right? The mu, we just forget about it, just getting all the thing. Okay. Of course, okay. And this is what? This is, you focus on particular group I, okay, and calculate the mean of the group I, right? Just adding up everything in I divided by how many of them, right? So suppose you want to care about the mean of the boys, right? Just add all the boys divided by how many boys you have, right? You have a mean of girl and add everything the girl, right? The first one is you add all the boy, the girl, the alien, the dinosaur, adding how many creatures you have. Uses big N. Okay? With big N is adding N1 plus N2 plus N3 up to NC, right? Big N is the how many number of animals or creatures in total. Okay. And as you said, once we've done this, okay, and we'll say these are all unbiased estimates. Okay. And turn out that we'll use this to calculate something very important we talk about after the break. Okay. So these xi and xi, x bar and xi bar will be very important. Okay. So, but before we go to the break, let me calculate this x bar and xi bar, which is something trivial. Okay. X bar is just adding all the things up divided by total number of them, right? So it's basically adding everything there, right? Just that what I see. Divided by 12 is 4. And how to get the x1 bar is just adding all this 4 divided by 4. How to get this x2 bar, mean of the 2, is just adding everything you see in the 2, then you divide it by 5. And here the last one will be how you get the 3 is adding all the 3 up, right? Then divided by 4. So it's 255. Now once, is that okay? And once of this is the thing we talk about after the class, after the break, is I know many group there, okay? And I want to see they all have the same mean, right? The question is, before t-test asking that 2 minutes sake. Now we make it efficient. Ask, is it all group the same? Is it man, same as woman, same dinosaur, same as alien? Okay. And on the other end, are there treatment effect, right? Because remember what we say is about, is any different combination of the water, sunlight, fertilizer, all the thing be different. Why I want to do that? You ask, why don't we do the t-test and do one by one, then we're done, right? You can do that. But when you have many groups, then t-test will be very inefficient, right? So turn out that if you do many groups together, you can do f-test, and once and for all, once you're done, we're done. Okay. And for example, when you do experiment, right, you have different, you have a new medicine, but you will apply different context, right? How much, what's the amount you put it to the patient, right? Maybe 1 pill, 2 pill, 3 pill, 4 pill, 5 pill, and many kind of combination, right? Combine with food, combine not with food, those kind of stuff. Then you want to see, are they different? Right? And say marketing, right? Remember at the beginning, right? We may not just want to compare difference between Hong Kong and Shenzhen. Right? You want to say maybe you want to Shenzhen, Hong Kong, Shanghai, and Beijing, 4 cities. And if they're different, right, then maybe you want a different mechanism, different marketing channel, different marketing strategy, right? Or marketing technique. So that would be the idea. And interestingly, although we're comparing mean, later you will see, because we assume they're same variance, turn out that by comparing some variance related to the X bar I and X bar, the grand mean and the group mean, you can do an F test, okay? And this F test is a one-sided F test. We will talk about that after the break. That is a little bit interesting result because you can compare mean, but at the end compare variance. Something a little bit surprising, okay? But at this moment, I guess I have a break because I know you guys are very tired. Always, obviously. So let's have a break of 15 minutes as usual. I'll resume at 3:35, 3:33, sorry, 3:33. Okay. So let's see how we're doing. Will I go over past test paper? I mean, I mentioned at the very 2 weeks later, I think we cover everything, then we have time. So that's why I will skip two-way and over, because I make sure I have enough time to go over the past paper. So the past paper, I will do it on the 24th, okay, of this class. So 2 weeks later. We're tired. Sorry, Monday. I mean, you're tired. Have more sleep. It's very important. Because your brain is still growing every time. If you don't have enough sleep, your brain doesn't grow. You can't remember. I mean, your brain is still going. The brain cell is also still dividing. So if you don't have enough sleep, then you can't learn very well. Okay, everyone knows Monday though, so not that tired. Okay. I hope the typhoon doesn't affect us. Variance, grand sample mean, Excel formula, Excel formula to calculate t-test. Decomposition, ANOVA, yes. Just remember, ANOVA is comparing the mean of many groups and asking are they the same or different, okay? Which we'll do it immediately. Okay. The over is okay, it's not that bad. Most of you still can follow. No, okay. At least we don't have more than half of people are super tired, but I can still see some of you tired. Understand? That's why I already examined you from the very last assignment. Okay, the ANOVA and the regression, the assignment I'll put there, but I'll put the answer as well, so you don't have to do it. I will put the answer maybe. I'll put the question maybe over the weekend or next week, and I'll put the answer by the end after I finish all the topic. So I'll put the answer there. Okay, so you can do it, or you have time, but you don't have to worry. No. So hope your dream become true, but TFE is not going to help anyway. But if there's no TX, there's no point. No expectation. Well, look at the past experience, and my cost variation is like above me a little bit, maybe within 1 SD. So whatever you think, let me know. Just tell me what you think about the class, so you will benefit in the future, right? Whether you like it or hate it. But I very few of time people leave quantitative comment, just like they like it or don't like it. If you like it, tell me what you like. If you don't like it, right, write down what you don't like it, because otherwise it doesn't have to serve the purpose, right? If you don't like it, at least tell me which part I can improve, right? Otherwise, it will go the downward spiral, right? But whatever you can do, just tell me. So expectation, as I said, right? The best estimator, look at the past, right? The past I told you is like my grade is usually the one for undergrad is usually about 1 SD above or 1 or 2 SD above, or maybe usually 1.5, 1 SD above the mean. And then for the graduate, I always get full mark, but undergraduate people are very demanding. But for the postgrad, I always get above the. So probably my teaching style fit more the postgrad undergrad. But anyway, that's it. So remember what we want to see is if different group mean are the same or not. Okay, so that is the idea. Okay, just to remember the starting point is like there's a farming thing. Let's see different combination of the farming technique lead to different result, right? Okay, imagine this is a very standard thing you want to see, right? Or if you're auditor, also the same thing, right? If you want to say, if you have a warehouse, right? Different role, you can pick up different thing and then see they're the same or not, right? If they're same, then actually the things are random, right? Imagine the warehouse, right? You have divided to many regions, right? You can sample different region and use the F test to see actually different region the same or not, right? So that's also one way to do it. Of course, you can do the T test one by one, but F test is more direct. Okay. So here comes a crazy 6 terminology, makes your mind blow a little bit. So if you're tired, you get more tired. The first one, which is something not very surprising, will be something related to variance. Okay. How to calculate variance? You subtract the mean and square and add up every observation. So SST is almost doing the variance. When you calculate variance, the whole thing, right? You look at every observation minus the overall mean and square, right? So this, this basically say for each group, L the group, or observation, you go over, you add up minus the mean and square, right? That's called the sum of square total. Okay, because total means everything. Okay, sum of square total. So there will be sum of squares. So that means that there are 2 other type of sum of square. Okay, and later you will see why we do that. All this is there will be different way to estimate variance. Okay, and the first later you will see is estimate based on assuming that the null hypothesis, all the mean the same, and you calculate this because X bar is a good estimate of the mu. Okay, basically just forget about you are say mu1 is to mu2 up to mu6 the same. This is the idea. Okay. Later you will see. So don't worry, wait a little bit. Okay, let's define everything first. So SSG. Here SSG, you will see I'm comparing each group's mean minus overall mean. Okay, so basically the same thing, but you replace this guy by the group mean. Okay, between group is replace each observation by its group mean and calculate the variance. The same thing. Right? So that's side. Okay. That is SS. Okay, SSG. The other way around is to replace the grand mean by its group mean. Okay. Okay. So there are 2 ways to do something variation. Okay. And you can do the math, turn out to be the SST with same as SSG plus SSW. Very surprising. But there is a just standard math manipulation can show you that if you do the overall variance, you can same as looking at within group, okay? Okay. Each one look at this, and okay, let me show you a picture. You will see why you have the blue plus the red equal to green one. Okay, let me show you the picture because this is not very intuitive. Look at the picture. Okay, look at particular observation here. Okay? Take this observation X, I, J. Okay, and this observation to the overall mean. Okay, and you square it for everyone. It's SST, right? Look at distance from one observation to the grand overall mean. Okay, and square it for everyone, right? That will be the SST, right? You add everything up. Okay, everything from the grand mean square is the SST. Okay, but this is a one-step approach, but you can do in two steps. One way to think about this is, okay, within group number one, you don't go to the grand mean. You go to the mean of the group. It's a red one. Okay, you go to the mean of the group. Go there directly. Okay, go to the mean of the group. Okay. Go to the center. And then next step will be from each group center, you go to the overall mean, right? From group mean and overall mean. Okay, that means that red plus blue equal to green. Okay, that's a math result, but of course that's the idea, right? You go all the way to the grand mean, but will be decomposed two steps. You go to the group mean and then from group mean to the grand mean. So that is two steps. Okay. Why this is true? There's a math behind. I'm not going to bother with the math, but the math actually not complicated. Actually 3 to 4 lines. Okay. So that is very simple result, but I'm not going to bother you with the math. Okay. Instead, I want to tell you how to calculate that and verify that formula. Okay. As I said, I'll just show it here to show you how to do it. And in the real world, it just the result give you Excel directly give you all this SST, SSG, SSW. Okay, but I have to tell you how to calculate that. But otherwise, you don't know what you're doing. Okay? SST is calculate everything from the overall grand mean. Okay? So how do we get 4? Remember how we get 4 is adding all the observation divided by 12, right? And how you do it is you take every observation, right? Observation number 1 minus this guy and square. And you do the same for everything. You get another one, and here you get this guy. So subtract this one, right? And you also do the same. The third one, subtract this one, square. Okay. You do this for every observation. That's 12 of them. Everyone subtract from 4 and square. Add the 12 squared number up, and that's get SST, which gives you 70. Is that okay? Any question before we proceed? Okay. Every observation, subtract from 4 and get a square. Is that okay? Now, once you see this, then we can do the SSG. SSG, remember how we do it? Is replace every entry by its group mean. What does that mean? This means that instead of 1 1 1 1 1 1 1 1 2 4, you have 2 2 2 2. Why? Because this is 2. And you replace this thing by 5 5 5 5. And also we play this by 5 5 5 5, which is the average of this column. And you do the same operation as before. Once we replace it, you subtract from the overall mean and then square each one, right? So that's why 2 minus 4 and 2 minus 4, 2 minus 4, and 5 minus 4, and so on and so forth. Add up, you have 24. Is that clear what we're doing? Okay, because this is sum of square within group. So you go to the group first. Okay, every data go to its group mean. Okay, which is the red thing in the diagram we saw before. The first step, go to group mean. And next will be SSW. Okay. SSW is not looking at the distance from the grant. You're just looking at the distance. So it's not go to here, but instead you go to its own mean. This go to here, this go to here, this go to here. Right? So that's why 1 minus 2, 1 minus 2, 2 minus 2, 4 minus 2. And this 3, you go to 5. Okay. You go to here, right? Minus 5. Okay, it's not minus 4, right? Everything is based on this. Okay. And finally, here is this minus 5, minus 5, minus 5, minus 5 square. Okay. You will see you add up SSG and SW, give you SST. Is that clear? So this is from the each observation to its group mean, which is SSW, and SSG will be from each group mean to the overall mean, right? The same thing. Okay. And you ask, why I care about this? Okay, don't worry, we'll tell you immediately. So just wait for 1 or 2 more slides, and we'll tell you why. Okay, so we calculate that. That will help us to calculate 2 types of variance. Okay, let's go ahead. So we'll calculate variance in several ways. Okay. So the first one is called MST. MST is to estimate the variance, okay, which is sigma square. Okay. This is an estimator for sigma square. An estimator for sigma square, right? Look at each observation and add together, right? All the observation minus the mean and divide by n minus 1. Okay. So this is the way that you discard any information of the grouping, right? So forget about grouping, right? There's no group, just calculate the variance as usual, right? This is the way that you calculate variance without thinking about grouping, right? Which is SST, right? You forget about group, forget about adding all the data and calculate its overall mean and then subtraction, right? So it's this variance without worry about grouping. Go directly. So the second one is called the MSG. Okay. What is it measuring? Okay. It is measuring. Do I have the graph? Let me see. Okay. Let me show the picture. MSG is measuring more. You look at the data from here, right? You come up with sample mean. So you look at the data. Okay. This will give you an X bar, right? And look at the data in green, then you get another mean there, right? Right. Dinosaur, right? And there will be another group that give you another mean. I don't know where here. And this is going to be somewhere, I don't know, somewhere here, right? Look at the variation of each group mean, right? Then I can calculate variance as well. Okay. Let me repeat what I'm doing. Look at group, all the boys. You have the sample mean, right? Remember this sample mean also follow randomly, right? And this dinosaur also the group mean, right? The sample mean is all random variable, right? And I only use the sample mean, right? Calculate variance between the sample mean. Okay. Variance between sample mean. It also can help us to estimate the sigma, right? Because everything is the same variance, right? So this also has the variance as well. Okay. So later you will see this MSG is also okay some way to estimate variance. Okay. And MSW is also the way to measure variance. Okay. This is measuring within each group what's variance in each group. Okay. And you ask, okay, I understand this variance, then okay, this n minus 1, right? And why this c minus 1? Why c minus 1? Because you only have c sample mean, right? C groups. So minus 1 because you estimate the bar. So that's why c minus 1. Okay. Because you only have c groups of sample mean, right? So that's why c minus 1, right? Because suppose a 4 group, you only have 4 sample means, right? So minus 1 is just 3, right? Because remember, you estimate the grand mean, so that's why you only 1 degree of freedom less. Here, you estimate within each group, right? And minus c here, why? Because you estimate c of this. Right? That's a c sample mean you guess, right? So that's why you minus c here, okay? So how can we, what we're going to do at the end is look at the formula here. I just jump a little bit ahead, right? Is to compare MSG and MSW. Okay. Why we want to compare that? Okay. And we will use this as a right tail test. Okay. So we want to compare the group over the within. What do you mean by that? Okay. So the idea is following. Okay. What is, maybe I should have the graph over there. Maybe I should have that as well. No. Okay. The idea is the following. Okay. Let me open a little bit further, right? Remember, this is the problem. X bar here, right? This is the data. This is group 1, mu1, right? And for some reason, your data have the X bar 1 here, okay? And maybe another data set somewhere here, it's mu2, and you get the data maybe somewhere there, right? X bar 2, okay? So how do you calculate the value, right? Suppose it's a data, one of the number, right? And remember what we said is, sorry, I should use a color, right? And from here to here is what? I should use the same color, right? So from here to here is what? SST, right? But you square that, right? And from here to here is SSW. Let me see if I do it the notation right. The color, right? SSWSG, right? And remember the formula we have is G over W. Okay? So the question would be, okay, if we calculate the variance, okay, if they're actually mu1 is actually same as mu2 or other mu as well, right? So if you want the null hypothesis is mu1 equal to mu2 equal to da da da, right? These two variants should be very similar, should be the same. The variance calculated from these two. This should only capturing the variation, right? If SSG is super large, then they must be different due to the different location. Let me repeat this statement. If mu1 and mu2 or the mu are very different from each other, then SSG will be much larger than SSW, right? Because SSG is looking at each mean of each group compared to overall mean, right? If they are actually very apart. SSG, say suppose they're not the same, right? The other is following, right? If x1 is mu1 not equal to mu2, right? At least not true, right? Not means not x1, x0. That means that what does that mean? It means SSG must be bigger than SSW, right? Because SSG has two things. One is error in the sample, right? But also reflecting the distance between each group, right? And SSW is minus its own group, so that's why it's has no problem, right? It's always only capturing sigma. But SSG is more than the sigma, right? If X now is not true, right? Then SSG will be actually the MSG, right? Because I should be more precise, right? Because it's the MSG, right? Because look at the variance. So the MSG must be much bigger than MSW, okay? So that's why I want to use the F test to calculate the variance through the MSG must be bigger than the variance calculated MSW. Okay? Is the variance calculated between the sample mean were much larger than variance calculated within group, right? Because the variance across group, right, will capture the information whether the group are different, right? Within group don't have this information, right? Basically just asking, I look at the men and women, right? Look at the woman. Within the woman, the variance different between women and the men within the group. Okay? And I look at the variance between variation between the mean of the man and the woman and dinosaur, right? Then across different group, then they can't be very different, right? If the across group is very different, then they can't have the same mean. This is the idea. Okay, I hope it is not too crazy to see why this is true. Okay, to repeat, let me say it again. If actually the mu1 and the mu2 and all the mu are very different, then this guy will be very big because it will contain the information that they are far apart from each other. Okay, if they locate the same thing and actually MSG and the same as the MSW, right? Because they're capturing the sigma square. Okay, so that's why we do that. Okay, of course, if you don't really get it, it's okay, because I think when I studied that, I don't really get it, but at least I know how to operate that. Okay. Now let's look at this example again. Okay. We calculate the SST, SSG, and SSW, right? SST is look at each observation and minus the mean, overall mean, which is 4, and then square for each one. Okay. MST will be this minus this n minus 1, right? This n minus 1 here. It's n minus 1. And the C minus 1 and this n minus C, right? And C is 3 because we're free group here, right? So that's basically, these are all the simple calculation. And don't worry, the MST, MSG, MSW would appear in your Excel, right? So I think except in the optional assignment, I actually don't ask you to do that, right? You never do this, but optional assignment, I ask you to do that. But Excel already calculate everything, so you don't have to worry about that part. So what is important is to calculate they are the same or not. Okay. So in this example, you will look at the ratio of the MSG over MSW. Okay. So the ratio will be MSG over MSW, right? 12 over 0.5, right? Look at the variance estimated by these two, right? And it's a one-tail test, right? Because if null is false, okay, then the above will be bigger than below. Right? So you would just looking at this F test, right? Something like F, right? 0 from here somewhere, like this. Okay. And which F you're checking will be C minus 1 and minus C, right? Because for this mean square group, this C minus 1, right? This is M minus C, right? Because there's only C group of sample mean, right? So how can we check this guy? Okay. So that the question is, we have this is 2.347. So the question is, what is this value? Right? If this value is less than 5%, then we're done. We reject. We will say the mean is different. Okay. Otherwise, we don't. So the p-value will simply be 1 minus f this 2.347. C minus 1 is 2. And minus C is 12 minus 3 is 9. 292. So, and you calculate this guy, 15%. Okay. Then it's not sufficient to reject. Okay. So we would, in this example, we would say the three groups have the same mean. We can't really reject it. We can't really say anything. Is that clear? So I guess it's important to show you the Excel for this one. Okay. Because as you check out my past paper, that's actually I directly asked you the Excel. Okay. I just jump to it because we skip all this thing. Okay. So for Excel, unfortunately, there's no Excel spreadsheet function. You only can use Excel add-in. Okay. So let me show it to you. I'll do one way and over. So that is using the single factor. Okay. And let me get this number there because I want to show you directly how we operate that. Because some of you may actually want to do it. Okay. So let me quickly go to the Excel. Okay. But in case you don't want to handle it, it's okay. We can just see me doing that. Group 1, group 2, group 3, 1, 1, 2, 4, 3, 4, 5, 8, and 2, 4, 5, 9. Okay. So there are a number here. So what we're going to do here is now using the we need to get the analysis 2-pack comes in. So go to file, option, file option, add in. Remember, we do this in our topic 1. And NS2-pack here. Okay. And then we do enable it. Okay. We do this in the beginning already. We know it or how to do that part. And once you do it, it's appear here. Okay. And if you use Macintosh, there will be some way to do it, but same. Okay. If you don't know, ask AI, quickly tell you how to do it in the Mac. So once we click this, we go to data analysis, and you can see we have the first one, an over single factor. The second one actually two-way, but we are skipping it for the interest of time. But we just do the single factor. So basically, the data is here. We just click OK. And the input range will be just column A, B, C, right? So just highlight A, B, C there. Okay, highlight A, B, C. Once you do it, there's a label in the first row and data grouped by columns. Alpha is 95%. Right? And that's done, right? So it's very simple. Let's tell them a column, data is there, 5%, and then tell them where you want to output the data. Usually I just output next to it, okay? But you can do whatever you like, just here. And once you're done, Okay, okay. Then we're done. Okay. But let me save this file first. To the desktop first, in case you want to get it back. You want to see what's going on. Okay. So this number. Okay. So what you expect, I'm not expecting you to do calculation in the exam, right? So, I mean, maybe I will ask, but the main thing I asked in the old days is I ask you to look at this Excel, understand what's going on there, right? So this is very simple. This count is how many number of data, right? Sum is just adding all the data up, right? Average is average of this column. Variance is variance of this column, right? Nothing new there. The most important part is this guy, ANOVA. Okay. And as we expect, 70 is our SST, right? For my example, this is SSW, this is SSG, right? Cross group. Okay. Degree of freedom Y2, which is number of groups is 3, 3 minus 2, right? And within group is 12 minus 3. Okay. Maybe just write down here in case you would, right? This is SST, and this is SSG, and this is SSW, and this is C minus 1, right? And this is N minus C, and this is N minus 1, right? Where N is 12, C is 3, right? 12 because you have N is 12 because this, right? This is N is 12. Right? You have 3 group here, so that's why C is 3. Right? And MS, the column H, right, is coming from dividing F by column G, right? 24 divided by 2 is 12, 46 divided by 9 is 5.11, right? Is that clear? So this divide this equal this divide this equal to this guy. And remember how you calculate this F. F is what? F is MSG over MSW, right? Across different group over within this group. Right? So that's why this divide this give you this. Okay. And once you calculate this, how can you calculate this guy? This is simply, right? The p-value will be F, this 1 minus, because on the right-hand side, right? Because your right tail test, right? So right tail test, 1 minus 2.34783, and then degree of freedom is 2 and 9, 2. Because the F is left-hand side, so you have the 1 minus is the right-hand side. Okay? And you ask a critical value, the same thing can be done, right? This guy is simply F inverse 0.95. Remember, it's not 0.975 because it's a one tail test. One tail test, okay? The right-hand side is 5%. Left-hand side is 95%. Okay? And you put 2.9 here. Okay? So everything is clear. And 15%, you can't reject, right? So you can't say the free group are different. So I think that would be clear to you. And as you would check, I keep asking very similar question in the past. If I ask ANOVA, right, because I don't want you to calculate ANOVA by hand, right? So what can ask is just ask Excel, right? Maybe you can see in the past, I just missing out some of the entry, ask you to calculate the rest, right? That is something I wanted. Is that okay? Is there any question that I can help? Is that okay? Is that okay? Any question? Because that is how you do a F test, right? So remember, the idea is you want to compare the variance within group, that's MSW, right, within group. That will be just capturing the standard deviation, that's capturing segments, right? But if the MSG, right, look at the sample mean compared to grand mean, that also capturing whether the mean are different, right? MSG compared to the boys' average, the men's, the woman's average, the dinosaur average, right? And if they're all the same, then this variance cannot be too large. That means that MSW and MSG should be very similar under X now. If not, you will expect MSG is much larger, right? Because across groups should be very different, right? So that's why you compare the two variants. Okay? And you can see this F is not bigger than a critical value, so you can't reject it. Okay? So either use this column K or column J would do the same. Okay? If I give you either one column, you can figure out the rest. Okay? And you can see a 3 group, but you can do as many groups as you want. Right? You got 10 groups, also fine. And it's very often why we need ANOVA is because of you have many you do farming or do many experiments, you do different type of testing. It's more than A/B test, right? It's very complicated ANOVA. You have many possible combination. You want to see that different, right? So the main thing is, if you do many things, you do ANOVA first and see they're different or not. If they're different, then you can figure out which one to be different. You do a t-test afterward. Okay. So F-test is usually the first round you do whether they're the same or not. And once you figure out they're not the same, then you try to look at which one are not the same. Do the t-test afterward. Okay. Is there any question? Okay. We are done with ANOVA already. So we skip two-way ANOVA. So in the on Thursday, we cover regression. Okay, the ANOVA we're done because ANOVA is basically a generalized t-test. T-test is comparing two groups, whether they're the same or not. ANOVA is I give you many groups. They have the same mean or not? And how to test it is comparing the variance across group and within group. And you should expect that if they're the same, the variance across group cannot be different from within group. Okay, okay, that will be the idea. So, right time, I will see you on Thursday.